Yeah, good morning, students. In the last class, we had a discussion on synchronous bus, how the IO devices can make use of this synchronous bus for data transfer. Now, in today's classroom discussion topic, so we would like to discuss on asynchronous bus. Fine. So now I would like to share my screen. Uh, here, the today's topic for discussion is asynchronous bus. So the lecture objectives are: this session will develop students' knowledge in an alternative schemes for controlling the data transfer on a bus, which is based on the use of handshake protocol between the master and the slave. So in this particular session, so we are going to discuss about this handshake protocol, so which is used for asynchronous data transfer using this bus. So what is meant by asynchronous bus? So this is an alternative scheme for controlling of data transfer on a bus, which is based on the use of handshake protocol between the master and slave. So a handshake is an exchange of command and response signals between the master and the slave. So this is what handshaking is. It's a common thing basically when we want to communicate between any two devices. That first of all, the two devices has to be self-introduced themselves before actual data transfer progresses. So that is the required when we want to perform the data communication in a proper way. So that is what we are calling it as here in our CO terminology. We are calling it as a handshake. So it is a mechanism which is used for exchanging of the command and responses between the master and the slave. So it is a generalization of the way of slave ready signal which is used earlier. Okay, in the synchronous bus we have used this slave ready signal. We have used that. So a control line called a master ready is asserted by the master to indicate that it is ready to start a data transfer. Similarly, the slave also responds by asserting slave ready. So here master ready and slave ready, these are the two important signals, control signals which are transmitted by the master and the slave, so that they will exchange this information, these control signals, to indicating that so both master and slave is ready for data communication. So how the data will be transferred, so that it will be data transfer will be controlled by a handshake protocol, that we will see now. So the master places the address and command information on the bus. Then it indicates to all devices that it has done so by activating the master ready line. So this causes all devices to decode the address, and the selected slave performs the required operation and informs the processor that it has done so by activating slave ready line. So the master waits for a slave ready to become asserted before it removes its signals from the bus. So in case of a read operation, it also loads the data into one of its registers. So this is an example of timing of an input data transfer using handshake protocol. So this is a handshake control of data transfer during an input operation. So this is, if you see that this is a bus cycle. So T0 to T5, T0 to T5 or the timings, if you see that. So this is what the master ready signal and slave ready signal. So this is the address and command signals. So during T0, time T0, the master places the address and command information. So during this time 0, the master places the command and address information on the bus, and all devices on the bus decodes this information. So during time T1, master sets the master ready line to 1. So during time T1, so the master ready signal, control signal will be raised to 1 to inform the devices that the address and command information is ready. Fine. So the delay T1 minus T0 is intended to allow for any skew that may occur on the bus. Okay, so T1 minus T0, this is what the delay time is called it as a skew. So the skew occurs when two signals transmitted simultaneously from one source and arrives at the destination at different times. Okay, so this happens because different lines of the bus may have different propagation speeds. So T2, the selected slave, during the time T2, the selected slave having decoded the address and command information performs the required input operation by placing its data on the data lines. So at the same time, it sets the slave ready signal to 1. So if extra delays are introduced by the interface circuitry before it places the data on the bus, the slave must delay the slave ready signal accordingly. So the period T2 minus T1 depends on the distance between the master and the slave and on the delays introduced by the slave circuitry. So the T3 during this time T3, the slave ready signal arrives at the master, indicating that the input data are available on the bus. So the master must allow the bus's queue. So it must also allow for the setup time needed by its registers. So after a delay equivalent to the maximum bus queue and the minimum setup time, the master loads the data into its registers. Then it drops the master ready signal indicating that it has received the data. So during the time T4, the master removes the address and command information from the bus. So the delay between T3 and T4 is again intended to allow for bus queue. So erroneous addressing may take place if the address, as seen by some devices on the bus, starts to change while the master ready signal is still equal to 1. So during time T5, when the device interface receives the 1 to 0 transition of the master ready signal, it removes the data and the slave ready signal from the bus. So this completes the input data transfer. Fine. So now reflections part 1. So what is meant by handshake protocol? Any students, please can you answer that? What is meant by handshake protocol? So just now we had seen that the master and the slave will make use of this master ready and slave ready signals which can be communicated before actual data transmission takes place. So that master ready and slave ready control signal transmission is nothing but handshaking. So timing for an output operation, this is an output operation, how it can be done. So this it is essentially the same as an input operation. Okay, so in this case the master places the output data on the data line at the same time that it transmits the address and command information. So during this clock cycle T0, address and command information is placed by the master. Similarly, the master is also placing the data during this T0 time. Fine. So the selected slave loads the data into its data register when it receives the master ready signal and indicating that it has done so by setting the slave ready signal to 1. So the remainder of the cycle is similar to the input operation. Fine. So the master ready signal is activated during time T0. So like this it will be there when slave is ready. So during time T2 the slave is ready. Now it will read the data and it will complete that reading of the data during time T5. So the remaining operations will be same as similar to the input operation. Then what are the advantages and disadvantages of asynchronous bus? If you take that, the main advantage of asynchronous bus is that the handshake protocol eliminates the need for distribution of a single clock signal whose edges should be seen by all the devices at about the same time. So this will simplifies the timing design. So the delays, whether introduced by the interface circuit or by propagation over the bus wires, are readily accommodated. So these delays are likely to differ from one device to another, but the timing of data transfer adjusts automatically. So for a synchronous bus, clock circuitry must be designed carefully to ensure proper timing, and delays must be kept within the strict bounds. So the rate of data transfer on a asynchronous bus controlled by the handshake protocol is limited by the fact that each transfer involves two round trip delays. So that is, slave ready must wait for the arrival of a transition on master ready and vice versa. Okay, so that is two round trip delays are introduced in this asynchronous data transfer. So on synchronous buses, the clock period need only accommodate one round trip delay. Hence, faster data rates can be achieved in asynchronous bus comparing with the asynchronous bus. In synchronous bus, we will achieve higher data rates. So to accommodate a slow device, additional clock cycles are used. Okay, most of today's high-speed buses use a synchronous approach only. Fine. So now LOs are revisited here in this particular. This session will develop. This session will develop the students' knowledge on an alternative schemes for controlling data transfer on a bus, which is based on the use of handshake protocol between the master and slave. So summary about this particular CDT is that an alternative scheme for controlling data transfers on a bus is based on the use of a handshake protocol between the master and slave. A handshake is an exchanging of command and response signal between the master and the slaves. On synchronous buses, the clock period need only accommodate one round trip delay, hence faster data rates can be achieved. So most of the today's high-speed buses will use the synchronous approach. Fine. So this is the lecture outcome. So after completion of this session, you will be able to draw the timing diagrams for handshake control of data transfer during an input and as well as output operations. Now, this is a lecture level practice problem. So try to solve this particular problem. So thank you students. Thank you one and all.